Greetings, one and all. Great day for a webinar. And thank you for everyone who's dialed in or registered, etc. I'll give people a chance to come through the virtual turnstile. But at last count, I think we had 341 individual registrations, so no pressure, Ian. But before Ian kicks off the proceedings, just a reminder, folks, gee whiz, this is number 8 of the Stormwater Fundamentals series of 2025. So thank you for everyone who's keeps on joining and watching and commenting and asking questions, all that sort of stuff. Hopefully you guys are learning a whole bunch of stuff. That's what it's all about. And after today, we've got 4 more to round out the rest of the year. But if you're keen to find out more, just jump on those links you can see on the bottom right-hand corner of your screen. So if you haven't registered for the next one, feel free to do so. Um, Before I pass over the microphone to Ian, I thought I'd just give a very quick mention to the fact that sometimes I actually do work. Because I think some people think I'm a podcaster slash professional webinar host, and I'd like to think it couldn't be further from the truth. But who knows? But yeah, this project was literally installed yesterday. So this was a 22 square meter Filterra bioretention system in Hervey Bay. It's the first of its kind on the Fraser Coast, which is about 3 hours north of Brisbane. And this is essentially yesterday morning. And over the course of the day, we basically, myself and 2 guys from Ocean Protect installed it. So as part of the turnkey approach that we do, we design and install and look after it for a year. So you can see here, we basically inherited a hole in the ground, and we come in with the geofab on the base, HDPE liner on the sides, jute mat around the batters, and then under drainage, gravel, and then filter media, and then mulch, and then plants. Bit of scour protection on the inlet as well. And that's essentially the end product, our end solution. So again, from a different angle, more or less the same thing. And fundamentally, this will remain offline whilst the upstream construction activities are happening, and then we'll look to activate it. But by that stage, the plants will be very well established. So if you're keen to find out more about Filterra bioretention systems, just give us a shout. And we had a whole webinar on it last week, last month. So if you missed out on that, feel free to drop us a line or just watch the recording on the Ocean Protect YouTube channel. But I might stop sharing my screen because it gives me great pleasure to introduce actually today's speaker. And he's no stranger to the Stormwater Fundamentals series. He has given a webinar before to critical acclaim, super popular. And our presenter today is actually Ian Adams. So Ian's a director of Organica Engineering, and he's also a sustainability engineer. And I can't think of anyone better qualified to actually talk about integrated water management for buildings. And just a reminder, folks, if you Ian's going to give a presentation. So if you've got any questions, please put it in the Q&A. The recording will be made available on our website, and I'll include a link, and we'll also be sending out CPD forms very soon after. But it gives me great pleasure. Ian, please take it away, and thank you so much for giving up your time today to talk about all things integrated water management for buildings.
Thanks, Brad, and thanks so much for having me and hosting this. I'm very grateful. As you know, I can talk about integrated water management all day, and I would love to talk about it every day, except my kids and wife get really sick of me talking about it. So it's great to have this forum. So
Cool.
I'll dive straight in and share my screen. All right. Is that coming through all right?
Perfectly.
Great. So rather than introduce myself, I guess I'll just talk a little bit about my journey in this space. So I guess it all kicked off in 2006, where as a much younger and enthusiastic engineer, got to write the scoping study for building water efficiency for the Building Codes Board in my role at GHD, and really got to meet a whole lot of people and do a deep dive, I guess, on the issues around water efficiency, but also integrated water management. And over the years, I've done a lot of work in this space of, I guess, regulation and calculation of integrated water management, particularly at the smaller scale. So how do buildings integrate with the stormwater system and the overall How can they contribute, I guess, to water savings and flood resilience and drought resilience, those sort of things. Along the way, I've got to build the water calculator for the Green Building Council for Green Star and help them write their water and stormwater credits, and also worked with industry software like Storm, but most recently, I guess, more out of frustration than anything, I've developed our own software, InSite Water. So I'll talk a little bit about that today. But that software was developed for really Knox Council, where I was sitting in the planning department asking everyone to put rain gardens, but then those plans would go to the drainage department and they'd cross the rain gardens out and put in OSD. And I figured out it was more a software problem where they were using old bits of software and old spreadsheets that didn't really cope with the subtleties of integrated water management. So that's where this project came from. And since then, it got adopted in South Australia as the default software there. So it's kind of quietly chugging on. But really what I want to talk about today is buildings and integrated water management and exactly what it means to design, I guess, not just rainwater tanks, but an integrated system for building and why you do it. Like, why would you add this maybe slightly more complicated design to a building rather than just put all the stormwater that lead to the legal point of discharge and hook it up to rainwater? So let's start with the why, and then we'll talk about the how. So the big why for me is that I'm an engineer, and this is what Engineers Australia says we should all do. In the ARNR guideline, which is really the I won't say holy book, but it is the one guideline to end all guidelines. Endorsed, and the only one endorsed by Engineers Australia, I believe. We have Book 9. Now, very few of you have probably got this far into this rather verbose guideline, but if you go to the philosophy of stormwater management, it does say some interesting things about what we really should be doing to prevent flooding. And particularly in chapter 4, it talks about volume management, where really what we're trying to do is fix this difference that when we pave everything, we get this much spikier, much floodier hydrograph compared to a pre-developed catchment, which is much smoother. So I guess going back to my slides, in pursuing these big goals of how can we get cities to be more resilient and buildings to use less water and produce less waste, they've got this nice diagram, which is control peak discharge, harvest or infiltrate stormwater, or improve water quality. Interestingly, what's new in 2019 is it's added these two things to control peak discharge. So in stormwater design now, really, we're not just meant to be putting in OSD. We're meant to be looking at harvesting and infiltrating stormwater, i.e. rainwater tanks, and also what can we do to improve water quality. And that is where a whole pantheon of devices around, like rain gardens and proprietary devices and swales and also rainwater tanks come in. So I guess this is why I'm doing it. I'm trying to follow the guideline, but as an engineer as well, I love to optimize and simplify and really just try and find the small set of solutions that sits here in the middle. You know, what are the solutions for buildings that do reduce flow rates, like OSD, that do reduce the volume and take a lot of the volume out of the floods that we're getting more and more in our cities? How can we improve efficiency and improve water quality to the oceans and bays and make the rivers and bays more swimmable? You know, what is this small set of things that we can do? Unfortunately, the NCC, PCA, AS 3500 doesn't have a lot to say on this space. I did have another read this morning, and I think there's a new AS 3500 Australian standard on stormwater has come out, and it really doesn't say anything new compared to the last 30 years. So I was a bit disappointed there, but it does have a few high-level tips and tricks around an OSD tank. But really, there's a big gap, I guess, in official standards, which means that councils and water authorities, local governments, and engineers like myself have had to, I guess, take the lead and get much better at creating toolkits and answers and performance solutions to solve the big problems of urban drainage and water supply. So what are these big problems? So let's start with I guess the council perspective, because I do still sit in a council planning department at Whitehorse in Melbourne. And what we see is the suburbs getting paved, and they get paved fence to fence. And what used to be a nice big pervious surface in drainage network all of a sudden becomes completely impervious. And if you can imagine the volume of stormwater that runs off in a completely impervious development to council's old pipe on the street that was put in God knows when, designed to God knows what standard, suddenly gets twice as much volume from the same catchment. And so, flash flooding is a massive issue for all of Australia's 500 or so local governments. And whether it's townhouse development or densification of industrial areas, quite often it's the same thing of, just generating a heap more stormwater for aging drainage systems to deal with. And unfortunately, our drainage systems aren't particularly good at being upgraded. Knox and Whitehorse would love to just dig up a drainage system, duplicate it, add a whole lot of water sensitive urban design. But there's complications. We're sharing streets with optic fiber and gas and telecoms and water, and stormwater pipes really don't play well. So it's a very expensive prospect to improve the drainage system. I recently I was talking to a council engineer who's going, oh my God, we got a quote for $1 billion to fix our drainage system, and we only get $1 million a year in funding, and with that we have to compete with football clubs and childcare centres. So, what do we do? So fortunately, I haven't had to make up this stuff. There's been a lot of work in the last 35 years on integrated water cycle management and bringing buildings and development into that. And just as a reminder, what is integrated water management? It's about the water cycle. So in a forested catchment, when it rains, and I'm sorry, I know in Sydney it's been raining forever, but when it rains, about 20% of the runoff goes off, and that tends to be filtered and slowed. So stream flows are stable with high quality water, and about 80% of water gets evapotranspirated or infiltrated. Now, in standard engineering practice, well, what used to be standard 30 years ago, we'd pave everything, connect it to the legal point of discharge, straight into the pipe network. And what that means is you get 80% of water flowing off immediately and only 10 to 20% infiltrating and evapotranspirating, which makes flash floods worse. It causes scouring of the waterways. It transports all pollutants directly into the ocean or the receiving water bodies. And it makes urban heat island effect a lot worse because there's no natural air conditioning, no evapotranspiration, and there's not this constant groundwater recharge for the plants to draw on. So getting a little bit engineering and putting this all into a diagram, this is out of the AR&R. What we have is the pre-development flow, this nice blue line. Pre-development is the blue line or the green line, or a forested catchment might be more like this purple line. And this is a graph of a rain event. So imagine a 5-year storm. What happens is the storm happens, the runoff happens. In a forested catchment, it will be absorbed and evapotranspired, and the outflow into the waterways is fairly smooth. But a fully developed catchment, it could get really spiky, really floody. And we put the drainage system in here. But what AR&R is asking us to do is push more into retaining the volume of a rainfall event. And the best way to do that is with buildings and getting the buildings involved, because the buildings use the water, and you can start using tools like rainwater tanks or infiltration just to remove this volume. And if you remove this volume, that's the hydrograph you get. If you just add OSD, it doesn't remove any volume. It just changes the shape of the speed of the curve, but it doesn't actually necessarily reduce flooding on a larger scale. So what does this mean for buildings? Well, it means we've got a few toolkits that we then need to design properly and effectively and efficiently. And there's different ways of designing something like the humble water tank. So the building code's mostly taken the approach of cost optimization, one downpipe to a small tank to one or two toilets, and let's make it all as small and as cheap as possible, which is valid for the water savings. So on $1 per kiloliter, what the building code suggests is fairly good, 2,000 litres to a downpipe in, say, a residential setting. However, if we're doing multiple criteria, we're going to get a different design outcome. So coming at this as a civil engineer, an environmental engineer, we go, well, let's design a tank to have all these integrated water management benefits, which means it's a bigger tank. It's connected to a lot more downpipes. It may have some detention space in the top, so we don't have to duplicate and have OSD as well. And we'll try and use as much of that water as possible and as many end uses as possible. And also, let's add some irrigation in there to get some infiltration happening. And this is designing a tank, I guess, in a slightly different way to mimic that evapotranspiration, the infiltration, the volume reduction that Engineers Australia recommends. Now, this becomes problematic. Unfortunately, the AS3500 still doesn't have a method for doing charge pipes, which means for building designers, it becomes a performance solution under the building code. New Zealand got it this year, but for some reason it didn't get signed off in Australia. So New Zealand under AS3500 has a lovely guide for charge pipes that we could probably drop into a performance solution in Australia. But I recommend charge pipes. Quick tips for charge pipes is don't use stormwater pipe. It's too flimsy. You have to use pressure pipe or sewer pipe at the very least, because this is a pressurized system and stormwater pipe is too thin. You can put a shovel through it. And that's why charge pipes are getting a bad name. All the plumbers are using stormwater pipe and it just breaks too easily. So if you are doing this, use your pressure pipe and get your levels right. There should be at least a 300 millimeter distance between the outlet and the lowest gutter. So that's your basic integrated water management water pipe. So what I've done is built software, because the AR&R is a fantastic document, but what it doesn't have is worked examples or any sort of detailed guidance on how to design this stuff or size it. It lists all the things you should be doing, but it doesn't actually tell you how or give you tools to size it. It just says do software or be an engineer. So what the InSite Water project is basically taking this guideline and adding the numbers. Now, I'm not sure if the software is going to fall over if I jump in and all 200 of you jump on at the same time. But let's just try this. Actually, I'll just do a different project. That one's one of mine. I'll do here. So what this is, it's a fairly simple web app that lets people essentially do a planning application. So it's a high-level schematic design bit of software that'll tell authorities what you're doing, but also help people size it. So in the building industry, not every project engineer has a lot of time to be doing this stuff custom for a building project. They tend to be small scale, and you don't want your engineering fees to cost more than a water tank. So this is designed to be quick and just get people's details, I guess, and drop in some basic catchments and treatment algorithms into here. So the front end's designed to be fairly simple, but the back end, it's actually about 22,000 calcs gets done each time you change something. But you can imagine, so here's an example of a house. It's a townhouse. Combined roofs are about 900 square meters. They're connected to about 25,000 liters of tank. That could be a 2,500 liter tank per townhouse if there were 10 townhouses in here. And then maybe you could add a little bit of just pure detention to your water tank. And what this will do is it will do all those calculations for your different areas and your different treatments. It'll do a water balance, and essentially out of the back of this, it will spit whether you've met the various objectives. Um, uh, in there as well, there's a few sort of detailed sections for uh, people like civil engineers who love just having a little bit more um, time to play with this stuff. Um, so anyway, so what happens there is once you've used the software, it's pretty confusing first time you use it. You'll need probably to read the help files, but most people after they've used it a few times, this software becomes sort of 20 minutes to half an hour. And then out of the back end, it prints a PDF that's really designed for uh, authorities like myself to just be able to quickly read the reports, check the inputs and outputs, and just see if the design is up to scratch. So that's the really quick overview of the site. Of course, it's a 5-year project and it does get more sophisticated than that. But there is what I will say as well is there's an Australian-wide version, but there's also a South Australian version. And the South Australian version we've actually integrated into the planning system over there as like a default tool. You can use DTS or you can use the free InSite Water thing to work out your integrated water management system. So I want to talk a little bit about what the standards are. And I don't have a lot of time, but there are a few out there. But really, at the end of the day, it's normally the local council or the local water authority that is the go-to authority or the responsible authority for stormwater. And given that the building code really doesn't say much about anything here that I'm talking about, anything engineering, really you'll be dealing with the local council and the local water authorities and whatever other standards they use or you reference. So some of the standards that can be referenced, I guess, are the Vic EPA Urban Stormwater Management Guidance if you're in Victoria. This table is kind of really what it's about. And what it says is for this rainfall, so if this was Sydney, you'd be up about 1,200. In Victoria, somewhere between 5 and 1,200, but you get your local average rainfall from the Bureau. And then you look up whether you're in a sensitive area or a not sensitive area. So if it's just suburbs, you then might look at your target for harvesting your water on an average annual basis and how much you might want to try and infiltrate or filter, which means a slow release, like a very trickle release that would simulate infiltration. So that's one standard. As I said, in South Australia, there's a DTS standard in the planning scheme now. It works at various scales. Just very quickly, it asks you to save water because, hey, we never know when the next drought is around the corner. Manage peak stormwater flows and volume. So flows can be OSD or some sort of flow constriction device. Or volume can mean remove that volume of water from the flood water or from the water coming out of the legal point of discharge so that it reduces the downstream impacts. And also it asks you to manage water quality, which really at the end of the day is it's suspended solids, nitrogen, litter, and phosphorus, but it's the nitrogen that's probably the hardest to remove. So people tend to use that as a proxy for the other ones. Don't really have time to go into it, but we will send out this PDF and there are more detailed guidelines that you can look at. But essentially, we've come up with some fairly simple matrix of about, put in this size tank for this size property and try and reduce your site perviousness as well. And that will get you just a deemed to satisfy approval under the planning scheme, or you can use the InSiteWater software to do a more sophisticated approach, say, and which is particularly relevant, I guess, for commercial buildings. We also, in South Australia, we encourage permeable surfaces for driveways. So that's either as a permeable paving, which is expensive, but it's a lot cheaper than an OSD tank, or that might be infiltrating car parks into rain gardens, bottomless rain gardens, a bit like what Brad was doing this morning. Also want to talk about Green Star. So we've got a lot of points in Green Star. So Green Star is kind of the default large commercial and industrial and public buildings tool. So most major building projects in Australia will be registering for Green Star, just as the thing you do for a large building. In the new buildings tool, there is points for water in the water calculator, and there's two targets. So at a minimum, you expect 15% less. This is fairly easy. It means put in a water tank, or you can just do it with efficient fittings compared to baseline. 45% is the credit achievement. That's actually really hard, but you can do it with good efficiency and a really good performing water tank, plus a few other things around fire testing and that sort of thing. And exceptional, 75% less potable water is basically replacing everything but drinking taps. And that's hard, but doable. So that's the current target. But there's also water break protection, and this is up to 4 points in Buildings V1. And what this asks you to do is in line with the Australian Rainfall and Runoff Guide. It asks you buildings to reduce stormwater runoff on an average annual basis by 40% for 2 points and 80% across the whole site. Now, in large commercial buildings, it's actually really quite easy to do because you have a lot of water demand from having a lot of people in that building. And if the car park isn't too big, basically you can achieve these 4 points, 80% reduction just by having a good water tank that captures and reuses most of the water from the stormwater from the roof. If you have a car park, you can then add other things like infiltration basins or unlined rain gardens, and that will also hit these targets, or use pervious paving as well. So that's what's happening with Green Star, and I would encourage you to do this. You can use InSiteWater to calculate this, or you can use Music. We'll also do the average annual reduction calculation, but for Music, you've got to probably use a separate calculator to work out the water balance and demand of the rainwater tanks, because Music doesn't do that out of the box. Green Star also has these fairly familiar pollution reduction targets. So these are fairly in line with most of the guidelines out there, particularly the nitrogen and 45% nitrogen reduction. There's also points in Green Star with buildings for resilience. One thing I will point out is there is an exponential relationship between temperature and absolute humidity. So what this means, and I think what a lot of us are seeing in the stormwater industry and the buildings industry, is that the floods are just getting bigger and bigger and bigger. You know, half of Queensland's local government areas were declared disaster zones last year from this flash flooding. So 100-year long duration storm, this water tanks probably won't really help, but our drainage systems tend to work a bit better with the long duration stuff. It's the really short, high intensity flash flooding, I think the buildings can really help our catchments with. But, you know, Green Star recognizes that things are just going to get exponentially worse. So here's a Green Star building. This is one of mine. And what I guess great design looks like for a Green Star building. You know, I've really tried to do it in this building. So this is the Knox Regional Netball Centre. It's a stadium, indoor stadium for netball. And we had a performance solution where every downpipe goes around the back of the building to two 100,000 litre water tanks. Those tanks are connected to all the toilets, the laundry, sorry, there's no laundry, toilets, irrigation, and all the other water uses, except drinking and showers. So we also have rain gardens. So the car park drains into rain gardens, and a lot of the water is infiltrated and filtered on its way out. So we do hit, we got get full points for Green Star in here. So I'm about to run out, I guess, out of my talky time, but I'll just talk a little bit about all the things that are in our palette. And as engineers, there's a lot of great innovation out there, a lot of great designs. We've been doing this now for 35 years, since the 1990s. And the technology is coming on. I won't say we've solved all our problems, because there's still issues and you've still got to design and maintain these things well. But we have, you know, your litter separators, which are a good primary thing in any sort of kit. It's always good to keep the sediment and silt and litter out of your rain gardens if you can. You've got the more advanced cartridge systems. You've got pervious and permeable paving. My big tip for that is make sure there's a bit of storage with void space in compacted gravel under here, because if you put pervious paving directly onto impervious clays or impervious soils, they're not going to be pervious. And water tanks, particularly if you're larger buildings, they just tend to work really well. They hit all the water saving and stormwater targets. So it's really is time to revisit what we can do. If you want to sort of imagine it, here's one of my my diagrams, but depending on which of these metrics you're trying to hit, you have various tools, and rainwater tanks seem to hit all these objectives. But some of the things like efficiency, you might have your star rating for your fittings. You might even look at recycled water and irrigation and rainwater tanks. But water quality, you're probably going to be wanting more your biological systems, your rain gardens and bioswales, but your rainwater tanks will divert rainwater out of the stormwater and therefore get quality points as well. Peak flows, which OSD is still around. OSD is still, I guess, useful at a small scale for getting more water through old council pipes, but a large catchment scale, it's pretty much recognized that volume reduction is the way to go. And so getting water into the ground or capturing and reusing it is the way to go. Now, I'm not going to go too much, I guess, into the science and equations, just to say that I've engineered a lot of this stuff into the software that I built. I've read all the textbooks again, worked with the professors, double checked everything, put it all into software so that I don't have to be practicing my calculus every day. But the software tools, I guess, is a useful thing for things like the Swinburne method, and working out ideal flow rates and permittable site discharge, and then figuring out how to get rainwater tanks to meet OSD targets, which is a really interesting area of innovation in the last 10 years. And yeah, really how, what are these areas under the curve? How much volume do we need to be capturing? What are the flow rates we should be targeting? If you are doing OSD, it's building into the software exactly, how to size this, and also automatically downloading the data you'll need, so you're not jumping on the Bureau of Meteorology website and downloading IFD charts. That's all built into our software. The InSite software will size the tanks, allow you to design hybrid tanks, size your orifices for you. I'm trying to build a performance solution calculator for your charge pipes. That's a work in progress. Hopefully that'll get launched at some point soon. And generally give you some guidance on the different types of systems and do's and don'ts. So I don't really have time to go through it all today, but if I just, sorry, that's not the one. I don't want ChatGPT, I want Google. But if we go to the InSite website here, under resources, there are a lot of guidance for the different types of things that you might be doing. So guidance on infiltration systems, how to match it to your soil type, your basic design for a infiltration pit or trench. It's got basic practice on how to do your bioretention systems, green roofs, guidance on your OSD tanks, that sort of thing, and how to actually make this happen using the InSite software. So what InSite software isn't is it's not a detailed design tool. You still need to, I guess, check that your design is compliant against the various standards, council standards, engineering standards. Not that there is really anything in the building code for any of this, but your water authorities and your local council will have their guidelines. And also your engineering responsibility to do the right thing is also there. So also what InSite doesn't do is large catchment design. There are better tools like that, like XP, Swim or Music or Drains that do the larger scale stuff. So InSite's really designed for buildings up to a couple of hectares. So final thoughts, and then we'll open to questions. Really where I come from with software is that it can help with, I guess, understanding what these high level guidelines mean, like the Australian rainfall and runoff, and actually doing the numbers and coming up with a workable design fairly quickly for a building to hit these multiple objectives. So, if you're out there developing guidelines, really try and make them useful, and uh, they need to not ignore engineering complications. There are many ways of, I guess, of doing integrated water management wrong, and we just want to be aware that we're doing it well, because it can be great when it's done well. I still think there's more work to be done to promote engineering outcomes. I am a bit disappointed that there's not more integrated water management in our Australian standards. It's just missing still 30 years down the track. So I think we still need to do more work there. Um, and don't be afraid to do performance solutions because there isn't anything off the shelf for engineers to do in building design. Things like charge pipes just aren't in any of the codes. Don't be afraid then to use your engineering expertise and put in a performance solution, even though there may be complications, I guess, around liability. But I think, we really need to be doing our jobs in engineering for integrated water management for buildings. Um, and, I think at the end of the day, some of the guidelines out there are a bit vague. So it really still does come down to an engineered approach. But, I'm trying to play a useful role in this by developing I guess, the software that's going to come up with engineering answers for high level problems. So that's the end of my presentation, and I guess we can open it up to the floor. But a big thank you, I guess, for all the people who have helped here, including rest in peace, Peter Coombs, who had a big say in designing the South Australian stormwater. So thank you.
Thank you, Ian. And you managed to pack a lot of info into a very short period of time. So well done. The questions have come through. And just a reminder, folks, if you do have a question for Ian, please put them in the Q&A. And obviously, if you don't get your question answered, feel free to reach out to Ian directly. He had his contact details on the screen before, but feel free to share that screen again, Ian, if you like as well. Jeff Davey got in very early. I think he's referring to InSite Water. So Jeff asks, and I think he's biased because he's calling from, I think he's dialing in from Yeppoon. And so he asks, does this work for Central and North Queensland?
So yes, yeah. The the guidelines do work for tropical. However, bear in mind, tropical design is a different beast. In southern Australia, we have gutters. In Darwin, you might have big trenches next to a building because gutters are kind of laugh at your attempts to contain stormwater. A detention basin in Victoria that might be, something you can put underground might be a football field in Cairns. So, you've got to be reasonable with this stuff. But certainly, there's a dry season. Water saving, harvesting really helps. Keeping things green through the dry season. If you can take volume out of the system, it still helps. How much volume? If you ask the professors, they go, some volume is good, more volume is better. That's an argument, I guess, to have with authorities. But yeah, all the integrated water management stuff does work. Just really be aware of tropical issues like particularly mosquitoes, and just that IFTs can laugh at your attempts at engineering.
Cool. One question I've had, we've talked about this before, Ian, and I'm not sure if there's been an update to the Green Star code, was around the targets. The Green Star targets talk about, design outcomes or performance outcomes based on designs. Is there a risk that building operators, managers, owners will lose their Green Star rating if they don't maintain their assets to ensure ongoing appropriate function to achieve their targets?
So it is a great question. So, from a water authority point of view, it's difficult, I guess, trusting the building industry and building owners that these things will be maintained. You know, particularly the underground stuff can be hard to see and out of sight, out of mind. Um, uh, so, you know, I think it's a work in progress, but you know, definitely don't assume that they won't be maintained as well. You know, things like water tanks do provide value. The stormwater stuff, you know, does get maintained, sometimes only if it's blocked, but nevertheless, or quite often there might be a service agreement with someone like yourself, Brad. So definitely, you know, more work has to be done on maintenance, but don't just discount integrated water management altogether
Mm.
because of a statistical risk. Um, everything we do in stormwater is statistics anyway, in terms of predicting flows and frequency and floods. So statistically, if we can get a lot more volume into a catchment that is maintained, it's going to help statistically. And if no one is maintaining, then it's probably a great investment to maintain some of the stuff we have rather than necessarily
Mm.
build new stuff all the time.
But it'd be an easy inclusion into the Green Star code, wouldn't it be, to say, look, to demonstrate compliance with this target, you've got to design, install, and maintain these assets to maintain that star rating. I thought it'd
Yeah,
be
so
an easy thing to include.
that's it's complicated. So as an Green Star assessor, I can say the building tool specifically is a design tool. So it's
Hmm.
about the design of the building
Hmm.
and I guess commissioning as far as that goes. But then it will be handed over. And yeah, ongoing maintenance of complicated buildings is always, you know, something facilities managers have to deal with. And, you know, as far as I know, most Green Star buildings are looked after pretty well.
Okay, well, that's good to know. Sean Quilty, webinar favorite from Pitch Black Group and Quilty Engineering, he asks, regarding adopted standards and targets, do authorities ask to incorporate climate change, not just increase in rainfall, but also anticipating drier conditions, e.g. South Australia?
Very good question. I have my own opinions, but the Australian Rainfall and Runoff has just been updated to recommend a that climate change is put in. It still doesn't say exactly how, but um, if I have just updated InSite Water to include a climate change factor in OSD design. So if anyone wants to use that, you're most welcome to. I suspect there might be 190 people on InSite at the moment. The site is only designed for about 30 concurrent users. So if it's not working at the moment, my apologies. Just come back in an hour or two. And it actually that's not too bad. So in the OSD section down here, um, there is now a box to put your climate change factor in. And you'll have to refer back to AR&R Book 1, Chapter 6. But if you're an authority, you can just tell people what you want them to put in here, and that will apply climate change factor as per the new guidance from AR&R. My personal opinion is things are a lot worse than we think already
Mm.
in terms of climate change, um, and we really need to get on top of this. Um, uh, yeah, you can see the site's working pretty hard because of that exponential relationship between absolute humidity and temperature. Um, flooding is going to get exponentially worse, and droughts are also going to be exponentially worse because things dry out faster when relative humidity capacity of air is greater with higher heat. So everything for me is exponential, which kind of scares me a bit as an engineer, but um, there's more and more guidance. Just try not to undercook it.
Cool. Another question. I think it's from Greg Bennett from Tasman District Council. I'm pretty sure that's in New Zealand. And Greg asks, similar to Jeff, have you looked at New Zealand codes and standards? I guess, long story short,
So
so you go.
yes, the good news is AS/NZ 3500.3 actually has a New Zealand only section on designing rainwater tanks, which is
Right.
really good. But for some reason, it says don't use it in Australia, but it's there for New Zealand. So I would jump onto Standards Australia and look at what the New Zealanders get. out of the new AS 3500.3.
Cool.
Apart from that, I
Sorry.
haven't seen many other guidelines, but if you want to send me some, I'd love to see them.
Question from Alec Mukomel. Apologies, I'm sure I mispronounced that from, I think it's Bayside Council. They
Hmm.
ask, what are your thoughts on drainage for showers on the foreshore? In brackets, where slash how do you believe they should drain?
Oh, that's a good question. Um, I'd have to take that just on the basic principles as an environmental engineer, because there's no guidance on that, and go, what's the risk? Probably the risk is people washing stuff, detergents. You've got a bit of a natural sand filter if they go into the sand, but that's a borderline one. It depends whether you want those detergents heading onto the beach or not. Probably fine. Um,
Cool.
Mostly,
Alex,
99% of the things just to not have drainage. But yeah.
Alex also asks, from what size of building slash roof do you believe rainwater tanks are net positive or worth it?
I think it's worth it on everything from a caravan up. Um, just because they have so many benefits for saving money on one side to reducing stormwater volumes out of buildings on the other. So um, I I'm a big believer in water tanks, but they work particularly well in high density. So Knox Council, for example, we get quarter acre block. They might be turned into 10 apartments. That might be like 30 people living on a quarter acre block, and they can use a lot of water. And we can somewhere normally require between 3 and 5,000 litre tank per townhouse, and that deals with all the impacts that that townhouse might have had, both on requiring more water from our old piping system because the water piping has capacity limits and that's not being upgraded, as well as our stormwater drainage system, which we pay for. It takes out a lot of the impacts. So, and it's a bit of a win-win. People get reduced bills and it helps with cost of living. So, um, uh, small, high dense is even better. Where you can't do everything with water tanks is in low density, quarter acre and above, low density greenfield. It's really hard to get the sort of volumes um, out of reuse required to meet these targets. It's much easier in higher density.
And there's a few questions around how hard it is to achieve these targets as well. Like when you were talking before, I looked up the Green Star building targets. It might be easier if I just share my screen if I can. Let's see if I can work out how to do this. Here we go. The Green Star targets. If you can see that this is obviously you'd be familiar with this book, Ian, I'm guessing.
Mm,
For a credit achievement, you need to achieve a 40% reduction in average annual volume reduction. So,
yep,
and for exceptional performance, you need to achieve 80%.
yep.
Now, that for me, just eyeballing that and being familiar with a few projects, that's actually really hard to do, particularly in space constrained sites. But also
Yeah,
recognizing that stormwater is often polluted. We obviously have solids and nutrients and gross pollutant targets, but we don't really have any targets for heavy metals or PFAS or et cetera. So there's a question mark as to whether the water could be safe for some uses at least. So
yeah. So
yeah.
that's an interesting example of, I guess, the easier it gets, the bigger and more dense the building is. So imagine a
Mm,
skyscraper. It's got a very small roof
mm,
and many, many thousands of people. So you only need a tiny rainwater tank, and that thing will drain immediately.
mm,
Um, every day it'll be empty. Um, so you can get almost 100%
mm,
reduction out of a small water tank for a skyscraper. So that's,
mm,
and for Green Star, that's kind of the base case. Um, so for Green Star, you then go down from there and go, well, anything above 4 stories is probably going to use all the water that falls on the roof with
mhm,
a moderately sized tank. If you've got car parks, really you probably want to then add a bit of perviousness and infiltration or unlined rain gardens to get more of that volume into the ground as opposed to straight into the stormwater system. So that's the approach. It doesn't work on every site.
mm.
If you're in expansive, contaminated, saline or impervious soils, the infiltration's not so great. But um, where it doesn't really work is everyone immediately thinks of a greenfield site where you've got a lot of green space, and it's where there's a lot of green space, a lot of gardens. It's hard
Mm.
to make the water tanks. do everything, and you've got to go to infiltration, which particularly in New South Wales is problematic, but in
Mm,
Perth, they don't have drainage pipes. It all goes
mm,
straight down. So it kind of depends on your catchment. Um,
mm,
which is why I guess a lot of this integrated water stuff does end up being in planning because it really is, a lot of it is
mm.
context related, and the building code doesn't do context very well. So a lot of this, the IWM ends up in planning.
Right. Yeah. Look, there's a bunch of questions I feel as though I met, but I know we're running out of time. One question from, I'm going to mispronounce this name. I'll just say Sabadha. Inside calculates part of the reuse volume, contributes to the detention volume. What if the pump system fails and is not maintained? This will lead to more runoff due to less detention. Similar question, I guess I asked before, I guess. Do you think?
Yeah. Um, so it's one of those things like we live in the world we live in. Um, and the same goes with detention tanks. Quite often they just fill up with silt and get blocked by leaves and they just after year two they overflow. Um, and don't do their job. So it is a tricky one. I think just um, you know, compared to upgrading the drainage system, everything else is cheaper and simpler. So
Mm,
I think councils and water authorities could invest more in having a few teams of people that went around and rebuilt rain gardens and serviced tanks and unclogged OSD tanks. I think it's something we don't do nearly enough, and I think Brad, we've had discussions at stormwater conferences. This always comes up at stormwater conferences. The lack of investment in maintenance. Um, but as I said, if every council the replacement cost for their drainage system is $1 billion, then getting industry to put in water tanks and having some doing some work around how they're maintained, I think is a great investment. Um, the InSite you can turn off the water tank
mm.
contribution because there's definitely a faction of people who don't want to do anything other than OSD, and that's fine. Um, so if you don't want to do that, um, if you don't want to account for dynamic volume in water tanks, you can just turn that off.
One last question, and I've actually seen this asked a few times, to me at least. They ask for tall buildings, do rainwater tanks need to account for the runoff from the facade? Is it
Yeah,
drained to downpipes or ground podiums? What's your thoughts there?
tall buildings we tend to ignore that, though there are
Mm,
methods for working it out.
right.
But it's tends to be largely ignored. It's just a bit of a difficult plumbing challenge for skyscrapers. Um,
Mm.
mm,
Cool. Hey, look, that's great.
um,
Just a reminder, folks, and big thank you to Ian for giving up his time. I'm sure I know I've missed questions, so apologies. And again, if I've missed your question, please reach out to Ian directly. And but just a reminder, folks, this is session number 8 of the this year's Stormwater Fundamentals. The next one will be on radial flow cartridge system. So again, register in your own time. And just a reminder for CPD, and we always get asked CPD. They'll be sent if you have requested CPD form, you'll be sent within a week. And obviously, the slides and recording from today's preso from Ian will be made available at that website you can see there. But above all else, thank you so much for everyone who's dialed in today. And also, thank you very much for Ian for giving up his time to share his pearls of wisdom around integrated water management for building. It's been fantastic. So hopefully we'll catch up sometime soon at a hip and happening Stormwater conference.
thanks, Brad, and thanks again for the invitation. It's great to chat to you and your people as always.
Sounds good. Cool. Everyone enjoy the rest of your day, and thanks again for coming along.